Welcome to the lesson on gradient, and here is our warm-up for this lesson. So you're asked to find the distance between the points -4, 1 and 6 and -2. So what do I always nag you to label them? That's right, label one of the points x1, y1, label the other point, therefore, x2, y2. So some people have asked, like, does it matter if that one's x2, y2 and that one's x1, y1? No, it doesn't. You'll get the same answer. Just so long as you commit to one of them has to be x1, y1 and the other one has to be x2, y2. So for instance, you can't call one of the points x1, y2. They have to be the same number, x1, y1. So find the distance between the points. Try to remember what is the distance formula. It's the one we've got little d equals big square root sign. Draw out your big square root sign. There it is. And then remember it's x2, it's the Pythagorean theorem. And what goes in there, it's not x2 plus x1, it's x2 minus x1. So 6 minus -4. So in brackets, 6 minus -4, all squared. Don't forget the square as well. Just reminding you that that's a negative. So 6 minus, subtract -4. Don't forget it's Pythagorean theorem, so plus y2 minus y1 all squared. So that's -2 minus 1 all squared. So again, just pointing out that that's -2 minus 1 all squared. Lovely. I drew a long negative. It's just a regular negative though. Plug that into your calculator. Forget how to do that. Remember, we can kind of show you on here. So do your square root sign. You can plug it in just like this. So you need your brackets, which are right down here. Bracket 6 subtract -4. Close bracket squared. And don't forget that now it's plus. What happens when I do this plus? Yep, it's in the right spot. That's good. It's not up in the exponent. Plus, open bracket, -2 minus 1. So -2 subtract 1. Close bracket. What have I forgotten? That's right, common thing. People forget the square. You can then just press enter, work out your answer. Write it out to lots of sig figs. So my float's not very high. You might have your float on a lot more decimal places, which would be better. And then write it out to lots of sig figs. For example, 10.4, then don't forget the ... What would that be to 3 sig figs? That would be, because of the 4 next to the other 4, 10.4. And if you want to write units, you can write units. 10.4 units. Lovely. And this, by the way, is a ... if you're wondering what that is. So 3 sig figs, of course, for your final answers. Write unrounded first and then round, in case you make an error in your rounding, so the examiners can potentially still give you a mark. Question 2. Solve simultaneous equations, these two simultaneous equations, using polysmalt on your TI Inspire. Or there might have been some other way that you might have found it. Maybe not with polysmalt, you might have found another way to use your graphing calculator, your TI Inspire, to solve simultaneous equations. So what you should do is grab out your Are You Not Yet Inspired task from week 1. You'll see there's a question where you're asked to solve simultaneous equations like that. Just like in this style where you've got x and y on the same side equals a number, x and y equals a number. Remember, you can solve with algebra as well, but I just want you to remember like how you did it from week 1. So all of you might have had a slightly different method, because as I said, this calculator that you've got, there's many different methods. So if you want, feel free to pause, look back on your Are You Inspired task from week 1, and write out the instructions that you have from your task. I'm going to soon show you another set of instructions, which you're welcome to write down. You maybe have the same ones, I don't know. But yeah, you definitely look at your own first, because that's better. You'll remember more because you've done it yourself once this way. And then afterwards, unpause and check out the version I'm about to write. Okay, so I'm going to show you a way. It's actually not using polysmalt, but it's something else. So what we're going to do is go to the calculator out, of course. Go to your home screen if you're not already there. And then it's a calculation. So we're going to go to calculate, for example. You can do it here. Enter. Oops. And imagine you didn't see that. So then press on to menu, because normally you wouldn't see what was there. So go to menu, and then you've got to go down to algebra, because it's an algebraic calculation. So once you've gone calculate, menu, algebra, you can take your own notes on this, then you would click open algebra. Try to think it's solving simultaneous equations. So you would select solve, the second one, solve system of linear equations. Let's do that. We've got two equations, that's good. Our variables are x and y. Let's go for it. So you could click on OK or with your hand, or you can go down like this, go OK, enter. Oh my goodness, what's going on there? Can I clear that off? Yep. Okay, so I'll just go back again. Menu, algebra, solve systems of linear equations. Okay, yep, that's better. That's what you should see. So what you've got to now do is just manually type in 3x minus 2y equals 16, and on the next line you've got to type in negative 2x plus y equals negative 10. So we can just do that using our keypad. So let's go 3x, remember our x is down here, 3x minus 2y, so subtract 2y, y is just down here, equals button is over here, equals 16. Then the next line is this one, negative 2x, so use the negative button, negative 2, click on x, plus y, so plus y, equals negative 10, equals negative button, 10. And then you can just press enter and get what the answers are. That's the answers. So the answer is the coordinate 4 and negative 2. So if you solve these systems of linear equations, you'll get the answer 4 and negative 2. So yeah, different ways you can do it as well. You might have had another way. So long as you got your 4 and negative 2 on the calculator, that's fine. Okay, so now let's move on to the actual lesson. You can take notes on how to do that if you want, just reminding you that it was, you went to the home button, then you went to calculate, then within once you were in calculate, you selected menu, algebra, then you selected the second one, solve systems of linear equations, 2x and y, and then you entered in the equation manually yourself. And that was the answer, 4 brackets 4, negative 2, so x is 4, y is negative 2. Okay, moving on to the gradient lesson. So gradient, you might have heard a little bit about gradient in the past. If it wasn't in regular maths lessons, perhaps it was back in maths investigations in year 7. Okay, so what is a gradient? So a gradient is a measure of how steep. So how steep a line is. So if you've got a gradient, you've got a line that's like this, if you've got a line that's like this, which one is steeper? It's the second one that I just drew. That would be a steeper one, so it has a higher value of a gradient. This one has a lower value of a gradient. You can also get positive and negative gradients. So if, as you're going from left to right, it's going upwards, it's a positive gradient. As if from left to right you're going downwards, it's a negative gradient. So that's a positive gradient, a negative gradient. You can possibly also get gradient values of 0, because remember back to maths investigations, the formula for gradient is the rise, this length here, divided by the run, this length here. But in this case, this particular one, what is its rise? It doesn't have any rise, it's just got a rise of 0. And its run, it's infinite, it goes on infinitely in the horizontal direction. And 0 divided by anything is just 0. So horizontal lines have gradients of 0. What about vertical lines? Let's think same thing again. Rise over run from maths investigations is how you calculate the gradient. It has an infinite rise. It's going on infinitely in the vertical direction. Does it have any run? It has no run. And remember what happens when you try to divide by 0? If you forget, let's see what happens in our calculators. Let's go back to here. Calculate. Let's just clear all that. So anything divided by 0, let's say for example 20 divide by 0. What happens? Undefined. It's not allowed. So it's because, as we said, in mathematics you can't divide by 0. Alrighty, so we say undefined. So if it's a vertical line, its gradient is undefined because in mathematics we can't divide by 0. If it's a horizontal line, it has a gradient of 0. They're important things to remember, by the way. And again, remember, because like dividing is like repeated division, so 21 divided by 3 equals 7, because from 21 you would have to subtract 3 7 times to get back to 0. But if you do, for example, 21 divided by 0, 21 minus 0 minus 0, you never get back to 0. You just keep saying it 21. So that's why in mathematics dividing by 0 is undefined. Let's move on to the general formula of a line. So you can find the gradient of a line if it's given in the equation for that line. So this is what we call the gradient intercept form of the equation of a straight line. So it's a special form called the gradient intercept form. The reason why it's saying y equals mx plus c, you're going to hear this a lot in this unit. The reason why it's called the gradient intercept form is this orange part, m, is what we call the gradient. Remember, uppercase M stands for midpoint, so don't use uppercase m. Lowercase m is the gradient. Y and x are just the x and y coordinates. M is the gradient, and therefore c is what we call the y-intercept. You might also remember this a little bit from maths investigations too, like when you had a formula for a rule for a sequence, like 3n plus 4. 3 represented the gradient of its graph, and 4 represented its y-intercept. Like on a graph, where does it cut the y-axis? Which you'll learn a lot about this unit. So find the gradient and y-intercept of this particular line. So what's awkward about this one is they didn't give it to you in gradient intercept form. But you can easily turn it into gradient intercept form if you go back to year 9. Remember transposition of formulas? So rearranging a formula to make y the subject. That's why you were made to learn this in year 9. Okay, so negative 4y equals 10. So let's make a little instruction for ourselves. Rearrange to make y the subject. So rearrange to make it y equals, basically. That's what we're trying to do. Requires a little bit of algebraic rearranging of formulas. So what you've got to think of, okay, I'm just going to be slack and just write the formula that's there already to begin with, just to get started. 2x minus 4y equals 10. What am I going to do next? We want to get y by itself, so maybe we want to subtract 2x from both sides. So in subtracting 2x from both sides, we'd have negative 4y on this side, and then subtract 2x from the right-hand side would just be 10 minus 2x. We don't know what x is, so we just have to leave it as 10 minus 2x. Then just a simple thing to get y by itself, we need to divide both sides by negative 4. Dividing the left-hand side by negative 4 just leaves behind. Oops. Actually, do you know what I did? First of all, I just happened to, you don't have to do this middle step, to be honest, but I just swapped these two around. Just so that when we have it in gradient intercept form, we've got the gradient and then the y-intercept. So I just changed 10 minus 2x to negative 2x plus 10. So technically this and this are the same line. I've just swapped those two around. Now what I'm doing is I'm dividing both sides by negative 4. So let's make a little instruction. Divide both sides by negative 4. This side divide by negative 4 just becomes y because the negative 4's cancelled out. This side divide by negative 4. You can kind of write it as negative 2x plus 10 all over negative 4. I don't have much space, so I'm breaking it up already. So you can break each one, or you can separately divide each term by negative 4. So I'm doing this term divided by negative 4 plus this term divided by negative 4. And then we do any simplifying that we can do. So for example, negative 2x over negative 4 becomes negative divided by negative is a positive. I'll do it up here, y equals. So you could say positive a half x, or you could say positive 0.5x. And then 10 divided by negative 4, what's that as a simplified fraction? It would give you minus 5 over 2, or you can say subtract 2.5, that's the same thing. So you could have had the decimal answer or the fraction answer. And now the great thing about it is you've got it in gradient intercept form. To see gradient intercept form, y equals mx plus c. M is the gradient, c is the y-intercept. So what is our gradient? It's the coefficient of the x term. So the gradient is positive 0.5, so it's got a positive gradient, meaning the line goes upwards from left to right as opposed to downwards. Its y-intercept is negative 2.5. So y-intercept equals negative 2.5. So if this was your graph, the x-axis, the y-axis it cuts the y-axis at negative 2.5 is what that line does. But it's a positive gradient, so it would go up like that. So that one's done, because you were just asked find the gradient and y-intercept. So it was just awkward that you had to rearrange to make it y the subject. When you make it into gradient intercept form, then it's really easy to see what the two answers are. So your transposition has to be reasonably good. Another example, find the gradient and y-intercept of the line 4 subtract y equals 3x. You'll want to get it into gradient intercept form again. Perhaps this one's a bit easier because you don't have as much to deal with. There's no coefficient on the y this time. So again, I was just a bit slack. I just rewrote the question to begin with. Took up a bit of space, unfortunately. And then you want to get y by itself, but to begin with, maybe you want to subtract 4 from both sides. So if you subtract 4 from this side, you're just left with negative y. Subtract 4 from this side, you're left with 3x minus 4. And then this is like saying negative 1y, isn't it? So to get y by itself, we need to divide by both sides by negative 1y. So negative y divide both sides by negative 1, sorry, not by negative 1y. Negative y divide by negative 1, so negative 1's cancel out. Then this side divide by negative 1. Interestingly enough, when you divide this one by negative 1, a positive divided by a negative is a negative. And divide this one by negative 1. Negative 4 divided by negative 1 is just positive 4. Make sense? Now you've got it into gradient intercept form. What is our gradient? Have a think about it. Yep, it's negative 3. So gradient, we've got a negative gradient this time. Negative 3, so it means a line from left to right is going downwards because it's got a negative gradient. And its y-intercept is positive 4. So it's kind of like saying, okay, this is your graph, y-axis, x-axis, it's going downwards and it cuts through the y-axis at negative 4. That's what that tells you. Lovely. Now you're asked to find the gradient and y-intercept of this line, 5x plus 2y equals 7. So just like before, you've got to rearrange to make y the subject, and then you'll have it in gradient intercept form. Then you just read the answer from the gradient is the coefficient of x, the y-intercept is the constant term. So again, I just have started by writing the question again. And then to get y by itself, first of all, we need to deal with the 5x. So you'll need to subtract 5x from both sides. So that leaves you with 2y equals 7. Subtract 5x. But I like to have the x first, just so when we have it in that form, we've got the x value at the beginning. So you could have written 2y equals 7, subtract 5x. You could then potentially write 2y equals negative 5x plus 7. Same thing, we just swap those terms around. Then it's quite easy, just divide both sides by 2. And I'm going to separately divide both terms by 2. It's the same thing as going negative 5x plus 7 over 2, but then you would have to separately kind of break it up anyway. I don't have much space. Negative 5x over 2 plus 7 over 2. We've divided off 2 from both sides. And then you could potentially work it out as a simplified fraction or a decimal. This is simplified fractions already, so this version is completely fine. You could, in which case the gradient is negative 5 over 2, and the y-intercept is 7 over 2. You could, if you wanted to, also turn them into decimals and have that form as well. Just so you're aware, there's two ways. Negative 5 over 2 is negative 2.5. 7 over 2 is 3.5. So what is the gradient? Remember, it's the coefficient of the x term. Once you've got it, you have to have it, first of all, in gradient intercept form first. So you have to have it as y. So you have to make y the subject first, as we have done. So the gradient is negative 2.5. You could have said negative 5 over 2 as well. What is the y-intercept? It's 3.5. So the y-intercept equals 3.5. Same thing as 7 over 2. Right, so pretty tricky transposition there, but you'll get good at it with time, if you're not already. So how can we calculate the gradient of a line? So in those cases, all you had to do, the gradient was kind of in the equation, you just had to rearrange to make it y the subject, and then you could easily get the gradient. So how can we calculate the gradient of a line? We generally use the idea like in maths investigations, gradient equals rise over run. Back to maths investigations. What is a rise? So here's your 2 points. So if you don't have them drawn in, draw in your 2 points. here and here, 2 coordinates. The rise between those two is the vertical distance between them. That's what the rise is. And the run is the, of course, horizontal distance between them. So we've got run in blue and the rise is the length in red. So different ways we can do it. This can also be written as a formula because if this is x1, y1, let's call that one x1, y1, call this point x2, y2, you could say rise over run in a different way. The rise would be the difference in value between the two y coordinates. So if this one is 7, this one is 2, then 7 minus 2, so the rise is 5. That makes sense, doesn't it? So y2 minus y1, the difference in the y coordinates, gives you what we call the run. Actually, I should have had it the other way around. Oops. So I'll just undo that. It's rise over run. That's the rise. Let's do that in a different color. So let's label this one not the run. Sorry about that. This is the rise. So let's write rise. So it's really hard to with the mouse pad. And then if you say, for example, this x coordinate is 10, this x coordinate is 3, the run would be 10 minus 3. So the run would be 7. So you take the second x coordinate, subtract the first x coordinate, gives you what we call the run. So it should say run here. So we'll do that one in blue so it matches the picture. So the run is calculated in this way. Lovely. Again, not in your formula booklet, but hopefully you're just going to know it so well after doing so many questions you won't forget it. So basically the theory, as I said, is rise over run, but if you label the points x1, y1, x2, y2, you can then easily just plug it into the formula like this. For example, find the gradient of the line through these two coordinates. So what do I always nag you to label them? I always nag you to label them x1, y1, then the other one has to be x2, y2. What we're going to do is just plug into the formula. The only thing is you have to remember the formula. It's not on your formula sheet. Plug it into the formula. So y2 minus y1 is 4 minus negative 2. Bit tricky. Sorry, so m, little m for gradient. Big M is for midpoint. So little m is for gradient. The rise is 4, subtract negative 2, and I just put a little reminder that's a negative button on the calculator used for that. So 4 subtract negative 2, and then the rise, basically the rise is to do with the y's if you forget, and the run's to do with the x's. So the run would be x2 minus x1 according to this formula. So 6 subtract 3 is our numerator. So 6 subtract 3 goes here. You might, I said, actually, to be honest, you don't need these little brackets here. So let's get rid of those little brackets. Because in the old days, you didn't have nice fraction buttons on your calculator, but nowadays you do. So you can erase these now if you want. And if you forget how to make nice fractions in your calculator, I'll show you just now. So erase them, because we don't need them anymore. You don't need them in your substitution step either. As I said, these were from in the days when you didn't have that nice fraction button. If you forget how to use the nice fraction button, just clear what we've got here. So we're in calculate. So nice fraction button is just above, see the nice fractions just above the divide sign. So go control, divide, makes the nice fraction button. So we go 4, subtract, negative 2, no need for brackets at all. 6, subtract 3, enter. And we've got a gradient of 2. That makes sense because if you worked it out by hand, 4 subtract negative 2, you can do that as well if you like, is 6. 6 minus 3 is 3. 6 divided by 3 is 2. But imagine you had some difficult numbers there. So then you could use the fraction button on your calculator if it was a non-calculator. I mean, if it was a calculator question. Nice and easy to plug into the formula. Let's do some more of that so we can remember the formula. Find the gradient of the line through these 2 points. Feel free to pause and try it yourself first, and then check with my answers. So assuming you've tried it yourself first, now you've unpaused and you're checking it, you might forget the formula on the previous page, so here it is. Gradient little m equals y2 minus y1, the rise, over x2 minus x1, which is the run. So I kind of have this typed. So sorry, it's y2 minus y1, negative 3 minus 2 on the top, negative 3 minus 2 over x2 minus x1, negative 1 subtract negative 5. Bit awkward. Negative 1 subtract negative 5. I'm just reminding you again that these are with a negative button. So those three in green are with a negative button, whereas these two are with a subtract button. Plug it into the calculator. Try if you've done that. Hopefully you got negative 5 over 4. If you want it as a fraction or as a decimal, negative 1.25, the same value. Let's do another practice just for the sake of repetition. So what's the next one? Find the gradient of the line through these 2 points. Don't forget to label. So hopefully you've paused and you've tried it yourself, and now you're just checking your answer with me. So the gradient formula, it's up here if you need it again. So y2 little m, equals, the numerator is y2 minus y1, 7, subtract negative 5, x2 minus x1 is 0, subtract negative 8. So notice I'm putting the negatives in green again. That becomes 7 plus 5, which gives you 12. That gives you 0 plus 8, which gives you 12 over 8, it should say, but I had to type it unfortunately. That fraction, because you can divide the numerator and denominator by 4, that means it became 3 over 2, or 1.5. So you can have it as a fraction, 3 over 2, or as a decimal, 1.5. Last one, same thing. Find the gradient of the line through these two coordinates. Label one of them x1, y1, label the other one x2, y2. Throw it into the formula. Little m, because don't use big M, because big M stands for midpoint. 3, subtract negative 4. Again, I keep saying negative button, not the subtract button. For the negative 4, 3 subtract negative 4 over 1 subtract negative 6. 1 subtract negative 6. Use the fraction button if you want to try it out. If you do it by hand, 3 subtract negative 4 is like 3 plus 4, 7. 1 subtract negative 6 is like 1 plus 6. So it's 7 over 7, which simplifies to 1. 7 divided by 7 is just 1. So there are different kind of ways you can be asked to calculate the gradient. So remember, the first way was if they gave you an equation. So if they gave you an equation and you were asked to just rearrange, like transpose the formula in the form of y equals, and then the gradient is just that coefficient of x and the y-intercept is a constant term, or they give you two coordinates, in which case you plug it into the rise over run formula, which can be also written as y2 minus y1 over x2 minus x1. I recommend using this one a lot. It's a very good formula to use. You just have to remember it because it's not in your formula booklet. Okay, thank you. That is the end of the lesson today.